All right, we are continuing our study of quadratics. As you know, in Unit 6, all we did was look at quadratics, the defining characteristics, what the parabola looks like, how to figure out if it opens wider, narrower, up or down, or all that kind of stuff, but we weren't solving quadratic equations. This whole entire chapter is about, our unit is about solving quadratics. At first, we learned how to solve by graphing. After we learned how to solve by graphing, we learned how to factor and then solve by factoring. And then yesterday we learned how to solve by square rooting. So the start thinking part says, go ahead and solve both A and B in any way you want. And technically that could be solved by factoring, solved by graphing, or solved by square rooting. So the first one, probably the easiest method of doing this is just solving by square rooting. So when you solve by square rooting, the main thing is not forgetting the plus or minus. So it is going to be x equals plus or minus 4. The next one, when you're solving this, could you go over and FOIL and factor and all that and get your answers? Absolutely. Could you solve this by graphing? Yeah, if you have Desmos close by. But the easiest way to do this one, because it is something squared in those parentheses, is just going to be solving by square rooting. So you can see the process. You get the something squared by itself. Don't go over and add 3 yet. You have to first go over and square root both sides, getting plus or minus 4 on one side. And when you add 3 to both sides, you end up getting 7 and negative 1. Same answers you would have gotten if you solved by factoring or solved by graphing. Now, I want to make sure you guys are being as lazy and efficient as possible. If you can solve by square rooting, always do that because it is super quick and easy as long as you remember the plus or minus. So as a reminder, when are you going to solve by square rooting instead of the other methods? If there is no b term, so when b equals 0, or if it's in the form of something squared equals a number. Doesn't matter what's inside those parentheses. It could be like x plus 5 or 2x plus 3. If you can ever get it to be something squared equals a number, then you can also solve by square rooting. A little bit trickier, but it still works. So those are the times that you're going to be solving by square rooting. So the next one says, can the following be solved by square rooting? And when you look at this, there is a b term, so can't do it because of that, and it is not in the form of something squared equals a number. So it looks like the answer is no, this cannot be solved by square rooting, and then you would go to factoring or solving by graphing. What we are going to learn today is when you have something in that form, you can actually mess with it and you can make it so that it is in the form of something squared equals a number. And it's this process that's called completing the square. So we know that it's very, very handy to be able to have an equation where you have something squared. So you can see in this table here, all of the left ones are something squared, x plus 4 squared, x plus 5 squared, x minus 3 squared, all of these things squared. And if you actually FOILed that, you can see the work in the middle, and you can see what you end up getting in standard form. So there is a connection between what it looks like in standard form and what it is going to be in factored form. What I told the students is that there is a little trick. That middle number, the middle term, the coefficient on the middle term, helps you find out what that last number is going to be, and then what is the number on the left that is going to be in your parentheses. So there is a little trick here. So students were looking and they were like, how can I make an 8 into a 16 and then it also gets the 4 in the parentheses? Well, it seems like it is just take that number and multiply it by 2. But then the next one would be 10 times 2, which is not 25. So that's not it. So they kept tinkering with this, and they finally figured out that all you had to do is take that middle term, divide by 2, and square it, and that would be the number that is on the outside. So once again, you can get that middle number and you can half it and square it, and that is going to be your C term. And then whatever the number was when you halved it is the number that is inside the parentheses on the left-hand side. So 10, half of 10 is 5, 5 squared is your 25. That's how you got that number there. And then half of 10 is 5, and you can see that there was a 5 in the parentheses. So they found out that that was the pattern. So when you add something like this, and these ones, when it is x squared plus 16x and we don't know what that number is, we can figure out what that number has to be. You just have to take half of 16, which is 8, and square it in 64. 64 is going to be the only number that you can put in here where when you did an ACB chart, if you do an ACB chart with x squared plus 16x plus 64, it will come out beautifully as x plus 8 and x plus 8, or x plus 8 squared. On the next one, the perfect number that would make this work is half of b squaring it. Half of b is negative 9 squared is 81. So 81 is that magic number. What do you mean it's the magic number? Well, if you did an ACB chart or your box method with this trinomial, it would factor into x minus 9, or x minus 9 squared. The next one, what is the magic number that would make this true? Well, half of 5 is 2.5, and 2.5 squared, you could figure out what that actually is. I just left it as 2.5 squared. That is the magic number that when this trinomial is factored, it would end up being x plus 2.5 squared. And the last one, the magic number that completes the square, that actually, if you did an ACB chart or the box method, is 49. If you had an x squared and a 14x, you half the 14, which is 7, and square it, which is 49. That's the magic number. I should have shown my work here, but if you did the box method with x squared plus 14x plus 49, and you did the box method, you would get x plus 7 and x plus 7, or x plus 7 squared. So there is a special number that completes the square, that makes it so that you can actually factor into something squared. So how is this going to help me? Well, remember what we talked about. You're only going to be solving by square rooting if it is already just x squared equals a number, or if it is something in parentheses squared equals a number. If you look currently at the x squared minus 12x plus 11, that is not going to be no b term. So it's not like there's no b term and you can solve by square rooting. And it is not written in the form of something in parentheses squared equals a number. So our deal is we want it to be. So we first see it, maybe 11 is that magic number. Maybe 11 is that beautiful number that is going to complete the square. Well, we check it out. Negative 12 divided by 2 squared. No, the magic number is actually 36 that we want there. The 36 will make it factor nicely, not 11. So it says, does 11 complete the square? The answer is no, 36 is the number. So since 11 is not the number we want, you can see that I just said, I don't even want you on this side anymore. So you subtract the 11 away from that side and the other side, and now you're left with x squared minus 12x equals negative 11. Now what we want is we want that left side to be something squared. So I have to say, what is that magic number that is going to complete the square? And we already learned the magic number that completes the square is going to be half of b squared, which is 36. You can see I added 36 to both sides. And once you end up having the x squared minus 12x plus 36, that we already know. If you did an ACB chart, it is going to factor to be x minus 6, or x minus 6 squared. Beautiful. We have something squared on the left-hand side. And if you add 36 to the left, you have to add it to the right as well. And when you add it to the right, now that negative 11 becomes 25. And we are at the point where it is something squared, x minus 6 squared equals 25. And that is square rootable. So we square root both sides, you get x minus 6 equals plus or minus 5. And when you add 6 to both sides, you end up getting two answers of 11 and 1. So that is the concept. In math, a lot of math is going, oh, I don't have what I want, and I'm just going to make it what I want. So in this case, we don't have what we want. We don't have something in parentheses squared equals a number, so we just make it into that form cleverly. Let's go ahead and look at these last problems that the students did. So on the first one, 12 is not the magic number. Half of 8 is 4, and 4 squared is 16, not 12. So that is not what we actually want there. So I get the 12 to the other side. Then I say, what is the magic number that would complete the square? Half of 8 is 4, 4 squared is 16. So I add 16 to both sides. You now have something that will factor beautifully, and the other side is now a 4. What does it factor into nicely? X plus 4 squared. Then you solve by square rooting. You get x plus 4 now all by itself. Square root of 4 is plus or minus 2. So you get negative 4 when you subtract 4 from both sides, plus 2, negative 4, minus 2. And you get negative 2 and negative 6. So this is the same, those are the same exact answers you would have gotten if you solved by factoring or graphing. It's just a different method of going over and solving. The next one, half of 6 is 3, and 3 squared is 9. 9 is not negative 16. So that is not the magic number that we want. So I just get rid of it. I add 16 to the other side, or to both sides. I then find out what is that magic number. The magic number is half of b, which is 3 squared. So I'm going to add 9 to both sides. Now x squared plus 6x plus 9, you can take my word for it that it factors nicely, or do an ACB chart if you want. If either way that you do it, you'll find out that it is x plus 3, or x plus 3 squared. When I added 9 to the other side, I got 25. And now it's just like the last lesson. I can solve by square rooting. Square root, you get x plus 3 equals plus or minus 5. And when you solve, you end up getting 2 and negative 8. Same answers you would have gotten by factoring. Same answers you would have gotten by graphing. And this last one is a little ugly. And the reason it's ugly is because half of 9 is not nice. Half of 9 is 4.5. So half of 9 is 4.5. 4.5 squared is actually 20.25. But we have a 20 there. It's close, but it's not exact. So I say, sorry, 20, get out of here. I subtract it from both sides. Then I do add the number that completes a square, which is plus 20.25 on both sides. You can take my word for it. You're going to have to take my word for it that factors to be the x plus the 4.5. It's always going to be the x and then whatever half of your b was before you squared it. And that all equals 0.25. You square root both sides. You get x plus 4.5 equals plus or minus 0.5. And when you solve, you get negative 4 and negative 5. Same answers you would have gotten when you solve by square rooting or by factoring. Now, the beauty of this, you might say this is way more work than factoring. This always works. Factoring doesn't always work. Many things can't be solved by factoring. Every one of these will work. All right, let's keep on going. Here's your homework. So you were supposed to fill in the numbers. What is the number that completes the square? And then go over and tell me what the binomial squared is. So half of 24 is 12. 12 squared is 144. That's your magic number. The other side is going to be the x plus whatever the number was before you squared it. So half of b is 12. The next one is half of negative 6 is negative 3. Squared is 9. Magic number that completes the square is 9. And then it factors to be x minus 3. The next one is half of 22 is 11. 11 squared is 121. And on the other side, it's x plus 11. The next one is half of negative 9 is negative 4.5. When you square that, I just wrote it as negative 4.5 squared. And on the other side, it's x minus 4.5 squared. On this one right here, it says that she did something. She did the whole process correctly, but this other person can't follow their work. How did they get from the x squared plus 12x equals 13 to something squared equals 49? What she did was when you half the 12, you get 6, and 6 squared is 36. So she added 36 to both sides before she went over and factored and simplified the right side. So she was jumping steps and didn't show that adding 36, and it was confusing for her friend who is looking over the problem. The next one, when you're solving this by square rooting, do not forget the plus or minus. This person, when they were solving by square rooting, they only got one answer because the square root of 100 was plus or minus 10. They thought it was just 10. So that is why they ended up with only one answer instead of 2. Now on these problems, go ahead and take a look. Every one of them, we moved the constant to the other side because it wasn't the number we wanted. We found the number that completed the square by doing negative b squared. We added it to both sides. We factored nicely, and then we solved by square rooting. You can take a look at the work here. The only one that is really confusing is the last one because half of 7 is 3.5, and 3.5 squared is kind of an ugly number. But each one of these, the number that was already there was not the number that completed the square, so we got rid of it, and then we found the number that completed the square. So there you go. All of those are solved by completing square. Same answers you would have gotten if you solved by factoring or by graphing. Once again, we haven't done any of the ones that are answers that you wouldn't have been able to get by factoring, but this always works. Solving by factoring doesn't always work because some things just can't be factored. Can't be factored nicely. And then on here, this last problem was just a review. It says, this is a quadratic. What's the equation? So I just made sure that it was quadratic by looking at the second difference. The second difference was 6. And remember the trick, all you have to do is divide that by 2 to find out what your a value is. So I knew it was y equals 3x squared. That wasn't enough because when you substitute a 1, 1 squared is 1 times 3 is 3. And I want it to be a 5. So I just went over and added 2 and made sure that it worked for all the rest, and it did. All right, this is a tricky lesson. Make sure you come and ask me for help. But it is, once again, the main thing is we are just trying to get it into the form where you can solve by square rooting. It's nice when we can solve by square rooting because it's easy. This is just not in the form of something squared equals a number, and we get it in that form. All right, thank you so much for watching.